In this particular question, we've been given the irrational function j of x, which is equal to x raised to the 2/5. And we've been asked to determine if this function has a point of inflection. Well, we start by taking the first derivative, j prime of x, and from there then we take the second derivative, j double prime of x, and we find that it's equal to negative 6/25 times x to the negative 8/5. We're going to set that second derivative equal to 0, and then what I've done in the next step is I've written it in slightly different manner so that I no longer have that negative exponent. So I have 0 is equal to negative 6 divided by 25 x raised to the 8/5, where the x raised to the 8/5 is all in the denominator. Now, what you'll see is that there is no way of taking this second derivative and setting it equal to 0, because that would require that we set the numerator equal to 0 and the numerator is equal to negative 6. However, we do notice that j double prime of x does not exist when x is equal to 0, because if I put 0 into that expression, I end up with 0 in the denominator and it's undefined. So I've got my x coordinate is 0. I go back and find my corresponding y coordinate by substituting into my original function j of x and find that y is equal to 0. So the question is, does the point 0, 0 represent a point of inflection? Well, we have to check to see if concavity changes across that point. So I put down my number line, place the 0 on the number line, and then I have to test j double prime x, which is equal to negative 6/25 x raised to the negative 8/5, and I'm going to check it at an x value of negative 1 and an x value of positive 1. Those are values on either side of x equals 0. They're also the easiest numbers to evaluate. When I substitute x equals negative 1 into my expression for my second derivative, I get negative 6/25. When I substitute in my x value of 1 into my second derivative, I get negative 6/25. So what you'll notice is that the concavity does not change across this particular point. The function is concave downwards to the left of x equals 0, and it is concave downwards to the right of x equals 0. Since the concavity does not change, then the point 0, 0 is not a point of inflection. And you can check that using your graphics calculator.